Good day, class. Welcome to this lesson on chapter 7.3 on electromagnetic waves. We will be continuing our study of waves today. I'd like you to turn your textbooks to page 121, where we will start. Now, I hope you're all familiar by now with the concept of the wave equation, where v, the speed of the wave, is equals to the product of the frequency of that wave and its wavelength. When we consider any electromagnetic wave, or light as we know it, we need to consider c, which is the speed of light through vacuum and roughly the speed of light through air. And that would equal 3.00 times 10 to the power 8 meters per second. Now this is a value that is in your data sheet, so don't try remembering it. However, it's really not hard to remember at all. We will then supplement our wave equation to form the wave equation for light by substituting c for the speed of the wave, which will equal frequency lambda. Now, since all waves travel at the speed of light in a vacuum, that means that all waves will travel at the same speed, and that just means that we will have all waves in some proportion of our frequency and our wavelength. If the one goes down, the other will go up, and vice versa. So, on page 121, we will continue here. This here states that electromagnetic waves are progressive transverse waves. However, unlike other types of transverse waves, they do not require a medium to travel through. So they can travel through the vacuum of space, or they can travel through air, they can travel to water, they can travel through U, depending on the wavelength and the frequency, and we will be looking at the different types as we go on. Now, as an extension, electromagnetic waves consist of electric and magnetic fields which oscillate at right angles to each other. So this is something we looked at a little bit before, and I will link a source for Wikipedia so you can actually see this in action. Completing this, we will find something like 1.2 times 10 to the power 6 hertz, which if we convert to megahertz, which is just 10 to the power 6, we find 1.2 megahertz. Okay, and that is question number 1. Let us move on to question 2. Question 2 asks us, calculate the wavelength in nanometers of an X-ray with the frequency 2.0 times 10 to the 18 Hertz. Okay. So we know our frequency 2.0 times 10 to the power 18 Hertz. We again know what C is. 3.00 times 10 to the power 8 meters per second, and they want lambda in nanometers. Okay, so let's apply our equation. C is equals to F multiplied by lambda. Therefore, lambda should equal C divided by our frequency. If we sub in our values, sorry, a little mistake there. Doing that, we will find our value to be 1.5 times 10 to the negative 10. They want their answer in nanometers. Nanometers we know is times 10 to the power negative 9. So we will shift our comma by one space, giving us 15 nanometers. Okay, and that is question number 2. Going back to our textbook, these 3 questions, question 8, question 9, and question 10, I'd like you to have a look at for homework. For a second now, I'd just like to swap over to a different source where we will do some further examples. Okay, so here we have the same information that we just discussed, which is basically that the speed of light is 299,792,458 meters per second, but that's a mouthful, so we use an approximation, which is 3.0 times 10 to the power 8. Again, reiterating that fact from earlier, when light travels from a vacuum into a material medium, glass, water, air, whatever it may be, its speed will decrease. However, its frequency remains the same. Therefore, the wavelength must decrease. Again, we characterize different forms of the electromagnetic spectrum by its different wavelengths. However, it's better to do that by their frequencies. And this is just due to the fact that the wavelength will depend on the medium, as was stated earlier, and that is why we use frequency, because frequency will always be the same. Blue light will be 400 nanometers, whether that be in air, light, water, same thing. The wavelength, however, will change. Okay, and here you can see the orders of magnitude again of wavelengths measured for the different types of light that we find: gamma rays, X-rays, ultraviolet, the whole shaboodle. But there are some things that we need to consider. As we said earlier, these divisions are arbitrary. They have no clear divisions between them. The naming of these divisions are also arbitrary. Sometimes some microwaves might be regarded as a subdivision of radio waves. As we've said, we've talked about the visible light from 400 nanometers to 700 nanometers, blue to red, which is visible, and then again nanometers, 10 to the negative 9 meters, and that the ranges of X-rays and gamma rays overlap. Now let's look at some of these questions. So I'm going to look specifically at question number 13. For each of the following wavelengths measured in a vacuum, state the type of electromagnetic radiation. Okay, so let's have a look. We have a wavelength of 1 kilometer. I'm going to switch back to my notes. Okay. So on a new page, we have example 13, and we are doing the following. We have a wavelength of 1 kilometer. C, again, we know 3.00 times 10 to the 8 meters per second. This can be written as 1 times 10 to the 3, if you like to, meters. And we require frequency, so frequency will be C over lambda. Okay, using this we can say we have 3.00 times 10 to the power 8 divided by lambda, which is 1.0 times 10 to the power 3. It will give us 3.0 times 10 to the power 5 hertz. Now we go back to the textbook and we have a look for what fits there. So these are on wavelengths. They're not very useful to us. Well, we can, since we have 10 to the power 3, which will be smack dab in the radio waves. If we're looking at the frequency from this textbook, we can see here our frequency of 3 times 10 to the 5 will be somewhere over here, nice and deep in the radio wave spectrum. We can continue with these questions furthermore, but I hope that you see at some point these become arbitrary and they become quite easy. So yes, that is it for our lesson on electromagnetic waves. Nothing too funny. What we should remember is that we use C for all of our equations. Very, very important. that you will usually use C unless stated otherwise. For example, if they give us the example where light is traveling to water, C might be different for water. So please use the one provided. If none is provided, use C as given in your formula sheet. Furthermore, we know that light is moving on a continuous spectrum. The spectrum goes from gamma rays on the high end of the frequencies all the way down to radio waves. This is something, unfortunately, that you need to understand. However, there are some tricks that can help you to simplify this for yourself. So what I would like you to take in is this region, the visible region 400 to 700, shorter wavelengths being blue light, longer wavelengths being red light, and everything shorter than this starts with UV, then X-rays, and then gamma rays. And everything higher than this, infrared, micro, and radio waves. Radio waves are in the range of meters to kilometers, so if you see anything like that, then you know what you're dealing with. Smaller than that, you have microwaves in the millimeter range, and smaller than that, we have infrared. And similarly, on the other side, anything bigger than 400 nanometers, yes, well, shorter than 400 nanometers, but higher frequencies than what the wave equation will give you will be ultraviolet, and then at some point our ultraviolet will swap over to X-rays, and our X-rays will get over to gamma rays. So if you ground yourself with that our wavelengths for visible light, we can infer everything beyond that. For homework, please complete these questions, starting with this table. Please work out the frequencies for me for all of these ranges. So start with the one, give me that one, and the bottom, for example, give me the bottom frequency, and then the top, and so on and so forth. So add to this table, and then complete these three questions, questions 8, questions 9, and questions 10. Thank you for your time. I hope this was informative. All the best.